For this question, we are going to find out what is the operating region of a given transistor PNP. The diagram given is excess minority carrier concentration under equilibrium, normalized to equilibrium concentrations. So from this diagram, we are going to find out what is the operating region. We know that one transistor can operate in 4 different biasing modes, which are given as ABCD as options. It can be forward active or simply active, saturation, inverse active, cutoff. So this is totally depending on the inbuilt 2 junctions which are there in the BJT. Every BJT consisting of 2 junctions. We know that one every BJT has 3 regions: emitter, base and collector. If it is PNP transistor, emitter and collector of P type and base is of N type. Then if you observe, emitter and base is going to be forming a PN junction. Okay, so this is called as emitter base junction, JE. And if you observe base and collector is of P type, base is of N type. So again it is forming a PN junction, which is collector base junction, JC. We are not writing JCB or JEB, base is common, so we are only indicating with one letter. JE means emitter base junction, JC means collector base junction. A PN junction is simply looks like a diode. Okay, PN junction means a diode. So a diode can be operated either in forward bias or reverse bias. So here BJT consisting of looks like 2 diodes. Okay, based on the biasing conditions of 2 diodes, that is 2 PN junctions, the BJT can be either in forward active, saturation, inverse active or cutoff. Remember that one, it is very important. A BJT cannot be equal to 2 PN junctions connected back to back, even though in construction, if it looks like in this diagram, it looks like a PN junction is going to be like this. A BJT is looking like this way. Okay, P, N and P. But 2 back-to-back connected diodes cannot act as BJT. Remember that one. Okay, false assumption. Now, we are going with JE and JC. How they are biasing based on that one, region of operation of BJT can be known. If both are forward biased, then it is called as saturation region. If emitter base junction is forward biased and collector base junction is reverse biased, it is active region or forward active region. If emitter base junction is reverse bias, collector base junction is forward bias, it is simply opposite of active region, so it is called as inverse active or reverse active region. And if both are reverse bias, then it is called as cutoff region. Okay, that means we must know from this diagram, okay, what about emitter base junction, that is JE, what about collector base junction, JC. If it is forward bias or reverse bias, whether it is forward bias, reverse bias, you are going to approach only one condition out of this 4. From that one you are going to say whether it is in operating which region. Okay, so for this one we need to know how a PN junction behaves in forward bias and in reverse bias. What happens to their carrier concentrations? That if you know, then you can easily answer this question. Okay, let us discuss PN junction. This is a simple PN junction under open circuit. That means open circuit means you are not applying any voltage, simply the 2 terminals are kept open. By that time, this is the charge carrier concentration under equilibrium in open circuit condition. PP0 stands for hole concentration in P side under open circuit or equilibrium. Under equilibrium, NN0 electron concentration in N type. In equilibrium, NP0 electron concentration on P side under equilibrium. PN0 hole concentration in N type under equilibrium. Okay, we assume that one P and N sides both are equally doped, so you are going to get this concentration. Okay, PP naught is this line, NP naught is this one. Minority carriers, majority carriers. Majority carriers, minority carriers on N side and P side. Now, if you apply forward bias, what happens? If you apply forward bias, what happens? That we are going to discuss. In forward bias, majority carriers will cross the junction. It will move from one side to other side. That we know it. So in forward bias, if majority carriers are moving, so that means the holes which are there on P side, they are moving towards N side. As they are entering into N side, they will become minority carriers and they are recombining with the electrons present on other side. So near the junction, more recombinations are taking place. As it is moving more and more distance, the recombinations are going to be gets reduced, and finally it is going to approach the steady state value of Pn naught. The same thing happens for the N side. Okay, electrons on N side, which are majority carriers, which can cross the junction under forward bias. As they are moving towards P side, they will become minority carriers. They will recombine with the holes present on P side. Near the junction, okay, near the junction, they are very large. Recombinations are very large, and as they are moving towards more deeper into the P side, the recombinations are going to be reduced and finally approaches the open circuit, that is equilibrium values of NP naught. These are going to be treated as excess minority carriers. This is excess electron concentration and it is excess hole concentration. Okay, totally it is called as excess minority carrier concentration. The entire one is called as excess minority carrier concentration. This is the excess minority carrier concentration diagram under forward bias. And under reverse bias, majority carriers cannot cross the junction, only minority carriers can cross the junction. So only NP naught and Pn naught can move from one side to other side. As they are becoming, that is this one, okay, electrons on P side, they are moving towards N side. They will become majority carriers and they will recombine with the holes initially. Okay, and as they are moving, recombinations are going to be gets reduced. So the holes are going to be at the near the junction, they are 0, and as the recombinations are going to be gets reduced, holes are becoming more and more and it approaches the final value. So as the electrons from P side, they are entering into N side, they will become majority carriers. Okay, and at the same time they will recombine with the holes present, and since near the junction more recombinations are taking place, so holes are very small. As the electrons are going to be coming into this side, they are recombining with those holes, so near the junction no hole is readily available. As they are moving deeper into the N side, the number of recombinations are gets reduced. That means number of holes or availability of number of holes are increasing. So this is the diagram it is looks like. The same thing is going to be taking place. Okay, so as the holes from N side, they are coming into P side, the number of recombinations near the junction are going to be more, so the availability electron near the junction is very small, and as the holes are going to be from N side, if they are moving deeper into P side, then the electron availability is going to be approaching the equilibrium value. So this is the excess minority carrier concentration under reverse bias condition. Okay, when normalized, this will become 1 and it will become -1. Okay, so because the difference from here to here is 0 to PnP naught, and it becomes 0, and this is PP naught. If you take logarithmic scale, this will become 0, this will become -1, this will become 0, this will become -1, and it will be very large, because majority carriers are very large compared to minority carriers. Okay, Now we will see under forward bias you will find a large carrier concentration above 0 with respect to normalized, and under reverse bias you will find minority carriers below 0 under normalized condition. Okay, now come to the actual diagram given. So this is emitter base junction. If you observe, this is emitter base junction, and here the carrier concentrations are below 0 line. That means emitter base junction is reverse biased, and this is collector base junction where the carriers are very large. It is given as 10 power 5 normalized value. So collector base junction is under forward bias. Since emitter base junction is reverse bias, collector base junction is forward bias. Okay, so this is related to this one, inverse active region. So the right answer for this one is C. C is the right answer, which is inverse active region. Thank you.